Hello everyone. I am Praveen BR, Assistant Professor from Department of Electrical and Electronics Engineering from Vidya Institute of Technology, teaching you all the microcontroller lab programs. So let's study today program number 2, that is writing an assembly language program to transfer 10 bytes of data from memory location 8100H with overlap. So what do you mean by with overlap? So whenever I'm transferring 10 datas, I'm taking from the memory location 8100H. The first address will be there. The first data will be there in 8100. The second data will be there in 8101. The third data will be there in 8102 till 8109. The datas are going to be stored. So 10 datas are going to be stored from 8100 to 8109. In with overlap, what we are going to do, we are going to place the set of datas, the same 10 datas, in such a way that we are going to initiate from the destination address is given within this 10 bytes of data, such that the already entered datas are going to overlap with each other. So let us see how to write the program. So we are going to write the program in a software called as Keel Microvision. So let us go to Keel Microvision software and see how to write the programs. So the first and the foremost step we have to follow in Keel Microvision is in the menu bar, we have to select the project window. So how do you select the project? In the menu bar, the fourth tab is the project. You select the fourth tab and you select new microvision project under project window. So all of you can see under project tab, the first and the foremost tab is new microvision project. So you click on next new microvision project. So you will be directed to a new dialog box where you have to create a new project. So since I'm creating a new project and this is going to be a project on overlap, I will give it as program number 2 and I will click on save. So you have to type the file name here and click on the save button. It will ask you to choose the microcontroller chip. So here I will be writing it as AT. So AT indicates that I am taking Atmel chip and I am using microchip under that. So which microchip I am using for 8051 microcontroller? For Keel Microvision 8051 programs, Atmel 8089C51 ED2 is the chip that is going to be used. So amongst the varieties that are shown, you are going to choose 8089C51 ED2. So all of you can observe here, I am choosing 8089C51 ED2. So this is coming under the vendor microchip. The name of the device is 8089C51 ED2, which is supporting the Keel Microvision software to execute 8051 programs. So I will click on the OK button here. So as soon as I click on the OK button, it asks me in a dialog box to save the startup copy. Since I'm using assembly program over here, I don't require to save the copy. So I click on no. So a target will be created. Most of the times students inform us that, sir, I'm getting an error saying target is not created. So if you get such kind of error, you might have made a mistake in any of the steps which I have taught you. So make sure that the steps are followed properly. So the target has been created for program number 2. I have to write the program. Where do I write the program? In the editor window. So how do I edit the program? How do I type the program? To type the program in the menu bar, I have to select file. I'll go to file. In the file, I will select new. So as soon as I select new, I'll get the screen. In the screen, I will type the program. So whatever program, assembly language program is there, I'm going to type the assembly language program. So let me type the program. So I have typed the program. Here, all of you can see I have typed the program. So let us see what is the program all about. So let me explain you the program. So the first step in the program is org00h. What does org00h indicate? I am originating from 00h memory location. What is sjmp30h? From 00h memory location, I am jumping to 30h memory location, which is the scratchpad area where I can type the program, where I can use, which is the memory space, which is specially used for the user to type the program and execute the program. So we start from 30h memory location, because from 00h it is used for register banks. I cannot make use of 00h memory location. So I start from 30h memory location. So I jump to 30h memory location. After I jump to 30h memory location, I have to again originate from 30h. So I give it as org 30h. Next, move dptr or move r7 comma hash 0ah. What does move r7 comma hash 0ah indicate? As I told you, the program is to transfer 10 bytes of data. So how many data am I transferring? I'm transferring 10 bytes of data. So to transfer 10 bytes of data, I have to use the same program is written for all the 10 data to be transferred from the source address to the destination address. So I form a loop. So once again, when I'm forming a loop, to avoid writing 10 times the same program, I am going to write a loop, and this loop is going to be executed until that particular condition is met. So to meet the condition, I have a count value. So the count value is 0a, that is 10, because I have 10 datas, and I'm using a register over here for counting. So I can use any register from R0 to R7. It is not mandatory that I have to use R7 only. I can use any register. So I'm using R7. So R7 will hold 0AH in its register. So 0AH is stored in register R7. Next, I want to transfer the data from the external memory location to the internal memory location. So there should be a pointer to point towards the external memory location. Who points it to the external memory location? It's data pointer who points to the external memory location. So your data pointer is a 16-bit address which points to the external memory location. So which is the external memory location? 8100. This data pointer is consisting of two registers. One is called DPH and the other one is called DPL. DPH stores 81 and DPL stores 00. So here the data pointer will be pointing towards the external memory location 8100. Here my program says I have to take the data from 8100H onwards. That is the reason I'm starting from 8100. Next, what I need to do, I need to transfer the data from the external memory location to the microcontroller. Who does it? Only accumulator. So my next instruction comes within the loop, because the same loop is used for transferring 10 data from the external memory location to the stack. Therefore, I am going to use a loop. So I call that loop as loop 1. So here move x a comma at the rate of dptr. So the data that is present in the memory location specified by the data pointer, that data will be transferred to the destination register, that is accumulator. So here the data that is present in 8100H is transferred to accumulator. Now from the accumulator, it has to be transferred to stack. Why do you use stack here? The stack is used because, again, for communicating with the external memory, I require accumulator. So I cannot hold the accumulator value, all the 10 values at the same time. So there is a temporary register which is going to hold the 10 datas in it is called as a stack. So stack is going to hold the data temporarily that is present inside the accumulator. So here what happens, the data that is present in the accumulator will be pushed to the stack. Stack is a temporary register. It is a special function register. The function of this special function register is to hold the data temporarily in such a way that the last input that you feed into the stack is the one which comes out of the stack. So when I say push 0E0H, 0E0H is the address of the accumulator. So the data that is present in the accumulator will be pushed to the stack. Every time when the data is pushed to the stack pointer will get incremented. What is a stack pointer? The stack pointer will always point towards the address inside the stack. The data that is present inside the stack will be stored in an address, and a stack pointer will be always pointing towards that address. Whenever I say increment dptr, I have already transferred one data. Next, I have to transfer the next data. Where is that data present? It is present in 8101 memory location. Who takes the next number? It is the DPTR who takes the next number. So the first number is transferred from the external memory location to the stack through the accumulator. Now the information is there in the stack. Now I increment data pointer. So when I increment data pointer, 8100 will become 8101. So what happens when it becomes 01? The data that is present in 8101 will be taken and again put to the accumulator. So I need not write the same program again. So I form a loop. To form a loop, I have a condition. What is that condition? djnz r7, loop 1. So what does this instruction perform? It checks the data that is present in R7. First, it decrements the data that is present in R7 and it compares whether the given data is equal to 0 or not. When it is not equal to 0, it is going to come out of the loop. If it is equal to 0, only if it is equal to 0, it will come out of the loop. If it is not equal to 0, this particular instructions are going to get executed again. So R7 was 0A, it gets decremented to 09. 9 is compared with 0. Since 9 and 0 are not equal, it will come back to loop 1. So move x a comma at the rate of dptr. Now your data pointer is pointing towards 8101, which is the second data. Second data goes to accumulator. From the accumulator, it will be pushed to the stack. Once again, your data pointer is going to get incremented to fetch the third data. This happens until all the 10 datas are going to get into the. So from 8100 till it reaches 8109, this operation takes place. Now I have 10 datas in the stack. Your R7 gets decremented all the time. So when the 10th data is arranged in the stack, your R7 will be equal to 01. It gets decremented, and once one is getting decremented, it becomes 0. So the data that is present in R7 is compared with 0. Since the data present in R7 is also 0 and I'm comparing with 0, they are equal. It will not go back to the loop. It will come away from the loop. So you have transferred 10 bytes of data from the source address to the stack. Next, what you're going to do, From the stack, it has to go to the destination address. So again, how many datas are there? There are 10 datas. So what we will do, once again, we'll take the counter value. Once again, I'll consider R7 itself as the counter. And now my destination address is 8105. It is not mandatory that I have to take always 8105. I can take 8102, 8103, anything within 8100 to 8109 for with overlap. Any datas I can take. So here I've taken the memory location 8105. So what does this do? This is going to store the last number that you have stored in the stack will be stored in 8105 memory location. So your data pointer will be pointing towards 8105. Next, what happens? From the stack, you are removing the information. Where should it go? It should go to accumulator. How does this instruction know that it has to go to accumulator? It says pop. So what does pop indicate? Remove the content from the stack. What happens when you're removing? Where should it go? It should go to accumulator. How does it know that it has to go to accumulator? 0E0H is the address of the accumulator. So it will go to accumulator. So the last data that you have fed to the stack will pop out of the stack and goes to the accumulator. Once it pops out of the stack, what happens? The stack gets decremented. In the case of push instruction, it had got incremented. In the case of pop instruction, after the information is transferred to the accumulator, it gets decremented. What gets decremented? Stack pointer gets decremented. So stack pointer got decremented and the information is there in the accumulator now. The data that was present in the stack is moved to the accumulator. But I want to move it to 8105. Who is holding 8105? Data pointer is holding 8105. So what happens here? The information that is present in the accumulator will be moved to 8105. Next, what happens? I have to go to the next memory location, that is 8106. So how do I go from 8105 to 8106? By incrementing the data that is present in the data pointer. So your data pointer gets incremented. Now, after I finish that, I have popped one information. There are still 9 more information. How do you know that there are 9 information? You will decrement R7 now. So you can see here, there is decrement jump no 0 R7. So what does this instruction do? It is going to decrement the data that is present in R7 and it compares whether it is equal to 0. Since it is not equal to 0, because I decremented 10 with 1, I got 9. 9 is not equal to 0. So once again, it goes to loop 2. In loop 2, what happens? The data that is present in the stack will be popped to the accumulator. The recent data is nothing but the last data that you have fed to the stack. So that will come to the accumulator. From accumulator, it will move to the external memory location. And this happens until all the 9 datas and 10 datas are transferred from the stack to the destination address. So what have I done in this program? I have moved 10 block of datas from 8100 till a memory location. That is from 8105 till 10 datas are going to be moved. So let us see how to execute this program. So once I have typed the program, the next step in the program is to save the program. How do you save the program? Go to the menu bar. In the menu bar, select File, go to Save As. You will get once again a dialog box. You are typing program number 2. So I'll give it as program2.asm. ASM indicates that we are dealing with assembly language program and click on save button. Click on save button. So this is how you click on save button As soon as you click on the save button, you can see that the color of the program gets changed. So this is indicating that the mnemonics are specified in, or the opcodes are specified in blue color, and red color indicates that they are all data. They are all data. Next, what do I do? After this, I will right click on target 1. I'll right click on target 1. I will select options for target 1. Why do I select options for target 1? Because when I'm executing, I execute it with a crystal frequency. What is the crystal frequency that I execute it with? The crystal frequency is 11.0591 megahertz. With this crystal frequency, I'm going to execute the program. So microcontroller operates at the crystal frequency 11.0591 megahertz. The crystal frequency is measured in megahertz. So you need not write mega once again. It is already in megahertz. So after you type 11.0591, you have to go to the output tab. You have to go to the output tab. In the output tab, you have to check the create hex file. So you can observe the create hex file is not selected here. You have to select it. After you select, click on OK. Next, you have to expand target 1. You get source group 1. You have to right click on source group 1. You have to choose add existing file to the group. Why do you do this? To the program, I am adding assembly language program what I have written. So I'm adding the files to this particular project. So I click on add existing file to the group. It will ask me which program. I am not doing C programming. I am doing assembly programming. So under files of type, I choose ASM. I have already typed the program here. So it is program 2.asm, which I've created. So I click on the given program and I click on add button. So when I click on the add button once, I can see that the program has been added to this project. Next, what am I supposed to do? I'm supposed to see the result. How do I see the result? I have to compile it first. How do I do compilation? You can find in the menu bar, the third row, you can find translate, build and rebuild. So first I click on translate button. So it is going to check whether there are any errors in my program. So I click on translate. It is going to check whether there are any errors. How do you know whether there are any errors? In the output window here, you can see 0 errors and 0 warnings. This indicates that there are no errors. Next, what we are going to do? Next, we are going to build. So I'll click on the build. So it will link the hexa file to this project. Next, I am going to say rebuild. So three things we are going to do: translate, build and rebuild for compiling. After this, we will go to the menu bar. In the menu bar, the fifth one we are going to choose, the sixth one we are going to choose, that is the debug button. Select debug button. Under debug, select start stop debug session. You are prompted to one more dialog box. You click on OK here. So this is the screen where all of you are going to be taken to. Here you are going to go to view because I am checking my output in the memory window. So where do you see the memory window? You go to the view button. In view button, you are going to go to the memory window. There are 4 memory windows. I require two memory windows here, memory window 1, memory window 2. Why do I require 2? Because I want to see the output in. I want to see the output in. The input is given from 8100 to 8109. Output is going to be overlapped over here. So I can either use only one window. So I will click on memory 1. So when I click on view button, when I click on memory window, and when I select this, I get the memory window here. So you can, this is the memory window. I am writing the program, or I am feeding the data in the external memory location. So how do I choose external memory location? With the help of X. X indicates that I'm accessing the data external memory location, and I write colon. Colon indicates that I am specifying which memory location. So external memory location 8100H. H indicates that I'm going to the hexadecimal memory location. So this is where I have to type the data. So this is 8100 memory location. I have to type 10 datas. Let me say I have 10 datas. One is 810. In 8100, I'm taking 01. In 8101, I'm taking 02. In 8102, I'm taking data 03. Like that, I will take 10 datas. So 1, 2, 3, 4, 5, 6, like that 7, like that 8, like that 9, and like that 0 and 8. So this indicates that I have taken 10 datas. So you can observe here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So where do you find the output? The output is used in 8105 memory location. So if this is 8100, if this is 8101, 02, 03, 05, 06, from this memory location onwards, the data is going to get overlapped. Means the last data that you have fed here will be given at this point of time. So let us check the output. How do you check the output? We are going to go stepwise. So let us see how to check the output stepwise. So to check the output stepwise, I use two things. Either I use the F11 key in the keyboard, or I have in the menu bar, the fourth one is step here, which will check stepwise. This is called the program counter. So what does program counter do? It is going to hold the address of the next instruction which needs to be executed. So it is in the first line right now, org00h. So this is the program counter which is holding the next instruction. So now I press F11 or I press this button. So one line is executed. So it has moved to org30h. Now you can find here your R7 is 00. Now I am putting some data into R7. So as soon as I press F11 or step, what happens? The data 0A will be loaded in register R7. So this is a count value. So you can see in this registers, R7 is loaded with 0A. Next, there is a data pointer. Initially, the data pointer is pointing towards 00 memory location. Whenever I say move dptr, comma hash 8100h, now your data pointer will be pointing towards 8100 memory location. So you can see it is pointing towards 8100 memory location. The data present in 8100 is 01. I have to move 01 to the accumulator. Your accumulator is 00. As soon as I go to the next step, your accumulator will become 01. That means I've transferred the data from the external memory location to the accumulator. Now, from the accumulator, it has to go to the stack. How does it go to the stack? With the help of stack pointer. The initial value of the stack pointer is 07. As and when you load the information into the stack pointer gets incremented. So when I load the information into the stack, 07 will become 08. So your stack pointer gets incremented to 08. That's how we get to know that the information is being loaded. So let us see whether the information has gone to the stack. So earlier it was 07. Now we have loaded the information. The data present in the accumulator is loaded in the stack. The next instruction is to increment dptr. So whenever I say increment dptr, one data is moved from the external memory location to the stack. Now it has to go to the second memory location. The second memory location is 8101. Your dptr is pointing towards 8100. When I increment the data present in the dptr, it will move to the next memory location. So I press F11. So it shows that the data pointer is pointing towards 8101. Now, instead of again writing the program for the second data, I form a loop. So for going to the loop, there is a condition. What is the condition? It decrements the count register and checks the data that is present in the count register, whether it is equal to 0. If it is equal to 0, it will come out of the loop. If it is not equal to 0, it will again execute the same loop. So R7 gets decremented to 9 right now because a minus 1 is 9. So it gets decremented. After it gets decremented, 9 is compared with 0. Since 9 and 0 are not equal, it will go back to the loop. Now your data pointer is pointing towards 8101. The data should be transferred to accumulator. So the data present in 8101 is 02, which will be transferred to accumulator. So you can observe that the second data has gone to accumulator. From accumulator, it has to be pushed to the stack. So your stack pointer gets incremented. And this procedure happens until you are transferring 10 bytes of data. So this is the third byte of data. This is the fourth byte of data. This is the fifth, sixth, seventh, eighth, ninth. Like this, it keeps on happening. So your accumulator has the last byte of data, which will be pushed to the stack. Next, it gets incremented to 810A. Now, it will check the register R7. R7 is 01. 1 is subtracted with 1. 1 minus 1 is 0. Since it is equal to 0, it will come out of the loop, which indicates that 10 datas are transferred. Now the datas are present inside the stack. It has to be moved to the destination register. Which is the destination register or destination address? 8105. So again, I'm going to take 10 counts because from the stack, it has to move to destination address. So you can observe here, I say R7 equals to 0A, which indicates that I'm moving 10 datas from the stack to the destination address. The destination address is 8105. So your data pointer will be pointing towards 8105. So this is 8100, 8101, 8102, 8103, 8104, and this is 8105. So the data 6 will be overlapped with A, and A will come and sit in this place now. So let us see whether it is happening. So what will happen? The data that is present in the stack will be moved to the accumulator and your stack pointer gets decremented. And from the accumulator, it will come and sit in this memory location. Which one? 8105. So you can observe that your 8105 became 0A. So one data is transferred from the stack to the destination address. Next, it has to be Next, it has to go to one more next memory location, that is 8106. So data pointer gets incremented to 8106. It will compare whether your register R7 is equal to 0 by decrementing the data present in R7. Your R7 gets decremented compared with 0. Since it is not equal to 0, it will go back to loop 2. In loop 2, it pops the data from the stack. The next data which gets popped out is 9 to the accumulator. So 9 gets popped out and stack pointer gets decremented. From the accumulator, it comes to the next memory location, that is 8106. So you can observe it is how happens. Like this, the data gets transferred from the stack to the given memory location. So you can observe here that the data has been transferred from 8100 to a specified memory location. Thank you for watching this video. If you have any doubts related to this, kindly put the comment in the channel box. Thank you all of you.